Welcome back to part 3 of the Razor Crest series, and in this video we're going to be going over HDRI lighting and V-Ray sun and sky systems. Now in this video we're also going to be going over some metalness and other material stuff, and as we progress through these tutorials there will be some overlap and some back and forth between different topics. In the previous video we were doing materials, and there's going to be a little bit more of that to come as well. So as you work on materials you do need to see what you're doing, so that is what this section is about. And if you're only interested in the dome lights or you're only interested in the sun and sky, check the chapter links below and you can just skip ahead to the part that you're interested in. All right, let's get started. Okay, so there are a few ways that we could start rendering. We can use dome light, so I want to show you how to create HDR dome light stuff. Like if you were to use Marmoset, Marmoset is basically doing the same thing. Substance is doing the same thing. Anything that you basically have like some kind of real-time view of the object and it's lit really nicely, and you're like, oh, it looks so nice in Substance, why does it look like garbage in Maya? Well, let me show you how to do it in Maya. Okay, so we can click on the V-Ray tab here, or you can just go to create and you can grab your V-Ray stuff from your lights section here, V-Ray lights. But I kind of like this panel now. I never used to, but here we go. I'm just going to use this, and we can grab a dome light, and by default the dome light is going to give you a pretty homogeneous, like ambient light, essentially. It's not what an ambient light is, though. That is different. In Maya, there is something called an ambient light, which is an abomination, and you should never use it. So don't use that unless you know what you're doing, basically. So what we need to do is grab our V-Ray frame buffer. So the V-Ray frame buffer, you can access that, and it's the same thing. A frame buffer is the same thing as a render view. So Arnold calls it a render view, and so does Redshift. But V-Ray is kind of old school, it calls it a frame buffer. And we can grab that directly by clicking this button here, or you can just click on where it says IPR here. Now the disadvantage of these, this one here is going to render like an entire sequence right away. So it's just going to start rendering a whole sequence if you have that set in render settings. This one does not even work with V-Ray. This is the Maya render view. IPR also starts rendering right away, which you might not want. So if you want to just open up the V-Ray VFB, you can grab that right here, and this will open this little window. I will explain what these are when it's important, but for right now, we just want to click this little teapot, which is green. And if you get an error down here that says, the license could not be found, this is what you do. So you open up a browser, you go to localhost :30304, enter, and this is the licenses that I have. So it will tell you what you have right here. We'll give you a warning if you have a PLE version. I grabbed the PLE just to see what was up and make sure it still worked, so I don't have that currently installed. But you do have to manually renew this, so keep that in mind. If you downloaded this right at the very beginning of the semester, for example, you will probably have to, well, in fact, you will certainly have to renew it before the end of class. And you can let it expire, it doesn't really matter, but just be aware that one day you might go into Maya and then try to render something and it'll give you an error. It's like could not obtain license or something. Sometimes that can be caused by the license server not even running. So if this never even loaded for you, it's just a spinning wheel or like a kind of 404 error or something like that. That means the license server is not even running. And to do that, you would have to go into Windows, go to your start menu and do that. I actually can't show you that on mine because I have a 4K display and I'm only capturing a small section of the screen just so the UI isn't so minute for you guys, because I'm not scaling my entire UI every time that I want to do a video. Okay, but if you need help with that, just let me know. But that is where you go just to check that everything is correct. Okay, so dome lights by default are going to be really, really flat, like a super cloudy day. Not particularly attractive. So we can stop the IPR, and then we could grab some kind of HDR image. So a really, really good site is going to be HDR Haven, or it's Polyhaven now, I guess. So Polyhaven. But they do have some really good HDRIs. So the HDRs here, they're all free and they're usually like massive. Some of these are like 16K. And yeah, they're really, really useful. So you can pick whatever you want, but I'm going to do something that actually has some bright light in it, like something that has, it's not going to be lost in shadow. So something like a desert. This looks like it will be good, and it kind of fits in with the theme. Now for the format here, there's a couple different choices. Well, actually a few on some of these. You can do 1K, 2K, all the way up to 16K. You really are probably fine with 4K unless you really want to zoom in on a surface and then see like super sharp reflections, which you might need. But I don't think that we're at the point where 16K is required in or like beneficial really. It's cool. It's like a future-proof thing. I'm sure everyone will be using 16K HDRs in a few years or something like that. But for right now, 4K is good. 8K is good. They're going to be good. 8K if you need to see super sharp reflections, basically, but usually the surface is not going to be super sharp. So 4K is good. And then for the format, we have EXRs and HDRs. Take your pick. They're both going to be pretty much the same. Click download. I'm going to save the file, and then I'm going to grab that image. So I'm going to paste that in right here. And then I'm going to go back into Maya. And then to use that texture, we say use dome text with the dome light selected. So if you clicked off this and you're like, how do I get back? Just go to your outliner or select the light in the viewport, use dome text. And then on the dome text, we say file, image name, and then we're going to load that in. Okay, so to see how this looks, we're going to open up the V-Ray frame buffer. So there's a few different ways that we could open up the V-Ray frame buffer. We could click this little button here, which opens up the V-Ray frame buffer here. You can also access that by just clicking one of these up here. This though will start a sequence if you have sequences enabled, so you might not want that. It can be like a final production render too. IPR automatically starts up the V-Ray IPR, which you might not want. So, and then this button right here doesn't actually open up the V-Ray IPR. It is just this button. So if you want to open this up and not render it, you got to open up this right here. All right, so we're going to actually stop that, move this over. There's a couple things we have to do here on the dome text. If I go back into our input here, by default, Maya will assume that an EXR file is going to be raw, but this is actually going to be very saturated. It's going to look a little bit incorrect, like too contrasty, or not contrasty per se, but the colors are too saturated. So usually HDRs and EXR files are actually going to be scene linear Rec 709 sRGB. And when you change that, you'll get a more realistic looking image here. This does, of course, depend on how it was made. But if we look back at the original image, you can see this is the color of the sand. This is what it's supposed to be. And if we set that back to what Maya thought it was supposed to be, which is raw, it looks very reddish. That's because the color primaries are different with raw. So it's not doing any kind of correction, but we do want to say, hey, this is supposed to be in sRGB space. So we're going to set it there. That's going to give us a more accurate render from the original. If you did want a richer color, you should go about it in a different way. You should just color correct that image with sRGB. Now, there are circumstances where you might be using an HDR that is actually raw. It just depends. Okay, so this is a little dark. So what we're going to do, go to our dome light, and then we can just crank up the intensity. And you might have to do this quite a bit. So, well, that's way too bright. Let's do something like 8 or, I don't know, something kind of like this. Now, something that is really, really useful about the new version of Maya is that it uses ACES color. So ACES color is a color profile system that allows interchange between lots of different types of cameras. So really, really briefly, I want to explain this in more depth, but it can get really technical, but really briefly. So when you're doing color corrections for film and you have lots of different cameras, well, every camera interprets color slightly differently. But it can mean that if you're trying to take two shots and make them look the same, like as if they were shot on the same camera, it can be actually a little bit tricky to do. So ACES originally was set up as a way to allow you to basically just pick the camera that it was used on, and then say which kind of format or color profile you want it to go to, and it will just adjust all the colors for you. And it doesn't matter what the source is. If the camera company wants to make a profile for it, they'll take that profile and automatically convert it to sRGB or X709 or whatever color space you're working in, and make sure it looks almost exactly the same. Okay. But for 3D, it actually became very useful because it also allows for tone mapping. So you can never have a value that's going to clip, which I explained in the previous lecture. You can't have values that go over 1 with ACES SDR mode. So SDR just stands for standard dynamic range. Sometimes this is also referred to LDR, which is low dynamic range. But that sounds bad, so I guess SDR is what they went with. HDR is high dynamic range, which on that survey, by the way, a few of you said that HDRs were something completely different. This means high dynamic range, SDR or LDR, low dynamic range, or standard dynamic range. So basically sRGB 8-bit. So this is great that you can say, hey, I want the intensity of this to be like white, but it's never going to completely blow out, really. The values here are always going to be 1 for the hotspots. Okay, obviously we don't want to go that crazy with it, but we do need to bump it up because by default it's way too dim. So we do want to make that a bit brighter so we get some bounce light. So maybe value of 4 is okay, maybe 5. It just depends. But ACES is going to give you a really nice natural look. So it might even be a little bit too bright, but hey, you can correct that later. So over here, if that's exposing too much, like an actual camera would, we could just lower that value, change our exposure and do stuff like that. So right now, that's just how you get an HDR in there. We don't have any reflections though, so I want to show you reflections. And by default with V-Ray, it doesn't give you any reflection value. So for this next part, I find it a little bit cumbersome to have the V-Ray VFB open. So I'm going to just stop this. If you have trouble with this next part, go back to just using this. This is good. But we're going to do it in the viewport for a lot of this lecture. So I'm going to click on the little V icon here. This is going to basically do the same thing, but in the viewport where we can navigate around. And if you've ever used Unreal, this is really close to how Unreal is, but it's not quite as fast. But the quality is very good, okay? And I think there's a future in which you might not need Unreal to do renderings. Like if you can do it all in Maya, but it's all real time, kind of what Redshift is trying to achieve with their Redshift RT, I think this is going to be really, really cool. Anyway, we don't have any reflections, so we need to change that. So we can just select this, and it's great that you can see it in the viewport too, which is good. But by default, the reflection color is black, and that's incorrect. It needs to be something, for PBR, it needs to be 100% white. Now, there are workflows where you could set this so it's not 100% white, but then you're not using PBR anymore. So you got to pick the workflow you want. In this class, I want you to use PBR so you understand it. It is probably something that a job would want you to be able to do. So on a job application, they're going to be like, oh, you need to be able to use PBR, the PBR workflow, or PBR surfacing or whatever. So you need to understand that. One other thing about ACES is that because it is color correcting the swatches, it looks gray to you. But if we turn off color management, you can see it is white. But we want to have color management on. It's going to appear gray just because it's color correcting everything. So that's one slight annoyance with using ACES, is that it does make this a little bit awkward. You can also, if I turn off the V-Ray frame buffer here, you can change this to untone mapped sRGB if everything gets too dark. But as you can see, untone map means that it's going to be way too bright there. This is what the HDR would look like if we didn't have ACES on, by the way. Like for the tone mapping part of it, it's super bright and clipped out. But with the tone mapping, it gives a really nice curve to fill in basically what your eye would see and what a camera would see for the most part. Okay, so back to V-Ray. So with reflections on, we have a much nicer looking image there. Okay, cool. So for this next part, I need to show you metalness. So metalness is kind of a a confusing thing, I think. Metalness basically means, is the object metal or is it not metal? And it's really not that difficult, but there's a lot of things that go wrong when you start doing bad things with metalness. And part of the reason is you have a slider. So you can start sliding up your metalness and be like, oh yeah, this is 25% metal or 30% metal or whatever, like 80% metal. And that's wrong. That's not PBR compliant. So PBR says it's either metal or it is not metal. You have 0 or 1. It cannot be anything else. It cannot be 0.1. It cannot be 0.99. It has to be 0 or 1. Because it is a binary operation. It is like, is it on or is it not? And if it's not, it does this weird curve where it's not doing anything that's physically accurate. So basically, the reason why there's a slider is because there are parts of the geometry or parts of the texture that might be metal and parts that might not be metal on the same UV set or the same texture map. There was a question, by the way, on the surveys, before I forget, the very first day. So I asked a few things. So just a quick refresher. Is this image good for a metalness map? And most of you said yes. But really, it's not. A few of you said, nah, that looks like a roughness map. And you'd be correct. This could be used as a roughness or a bump or a displacement or something. Can't really be metalness. Why? Well, there's grayscale values. Metalness is black or white. Okay, so that's what you need to use. And by the way, I see this all the time. If you grab some kind of PBR texture or you're exporting something from Substance Painter or Designer, and you get a pitch black metalness map, meaning that nothing on your object is metal, please don't load that in because you're wasting resources doing that. Like, Maya has to load that and do something with it. If it's just pitch black, leave the value as 0. If it's 100% metal, there's nothing else on the surface at all, don't put in a pure white map. It's pointless, okay? The only reason you might want to do that is if you're packing all your materials into like a single texture, but you still wouldn't ever have to hook up that node. So you don't need to worry about pure black or pure white metalness maps. Just use a value of 0 or 1. Okay, so for that, we actually do get a metalness map texture. If we go back to our RC textures here, and then we look at the metalness one, there are basically 2 values. We have black, and then you have white. Now, there are a few complaints that I have with this, that there are some grayscale values here. A couple values are technically acceptable with PBR, and when you're doing like fringes or edges, the value might get shifted a little bit, just with gradients. But you really want to avoid having gray values. So this would be okay. This is pretty good. The ones that are bad are things like this. Like, this is not metalness. I'm sorry, but like this is not. It needs to be black and white. So these things are things that we would probably want to go and correct later. I'm going to load these in as is, and it looks okay. It looks fine. But just keep in mind, if you are creating a texture and your metalness map comes out in grayscale and it's not just black or white, like it really should just be a mask, black or white, on or off, you probably need to go back and adjust it or fix something. Okay. So in this case, I think maybe there was some kind of opacity that was being used and it just didn't output properly, but I see this all the time, even professionally. So Substance has a really useful guide. If you're interested, I can show you where that is. So if you just type in Substance PBR, there's a PBR guide, part 1 and part 2, and they do explain how to use metalness and what metalness is supposed to be with a lot more depth than what I'm going to explain. But they have a really useful image here. This is what your metalness should look like. So people say that, oh, well, what about if it's rusty or something? Well, for the parts that are rusty, then it's not metal anymore. So you just say that it's corroded, so it's not metal anymore. Things that are also not metal are metal that is painted or metal that is dirty. So if you have anything that's covering just the base metal, the raw metal, it is not considered metalness anymore as far as PBR is concerned. It's just the raw metal. Okay, so for this, we actually do have raw metal, so we want to use that. I'm going to just toggle this on and off again so you can see what it does to the overall value. So this looks really shiny and really cool. I like it. But there are parts that don't really make as much sense. So if this was not metal, it would look very diffuse. Diffuse is like how the light just kind of falls over it, kind of spreads out over it. So it's pretty diffuse, but with metalness, it's going to be very, very reflective. Okay. And it's not going to use your diffuse color at that point. It's just going to reflect everything. But there are parts that we do need to have that dirt or those scratches or paint or whatever. So for those areas, that's what we need the metalness map for. So we can load that in, no problem. So we can grab our metalness map, go to File, and by default, it's going to say, hey, there's nothing there. It's just black. There's not metal anywhere. We can grab our metalness map from here. Same thing as always. This is something that you just have to know for UDIMs. If you see a number at the end and you have more than one texture, that's a UDIM. And when we load that in, by default, the color space is going to be wrong. We just say utility raw. And then we would need to do the same thing for the greebles as well. So I'm going to turn off the V-Ray view there just as we're messing around with this. It can just slow everything down. And if you have a older computer, it could end up crashing. So just bear that in mind. So save often. Metalness there, I'm also going to say alpha is luminance. And for our greebles, I'm going to do the same thing. This time I'll show you this one again. Tab, File, Texture. I'm going to name this first this time. Metalness. Greeble metalness. Grab this. UDIM. Change our color space right there. Alpha is luminance. And then another cool thing that you can do, if you have your main material selected over here in your attribute editor, you can go to your metalness here or whatever channel you're trying to do, and then just middle mouse, click and drag that node right there, and then release, and that will automatically hook it up. That's a really useful method of doing that as well. So whichever method you prefer is good with me. Okay, so now if we turn our V-Ray view back on, you can see that those greebles are now added. Okay, so now this is actually very, very bright now that we have all that metal. So we might want to go back to our light and then just tone that down a little bit and just get a slightly different view. There's also another type of lighting that I'd like to show you, and that's just using a V-Ray sun and sky. But I think it's probably more common that you'll be using HDRs, and you do need to know how to use them, how to use them properly. So I hope that was a useful guide there. If you have any questions on that, definitely let me know. The one other thing I wanted to show you, so if I select the dome light here and I try to rotate it, it doesn't rotate. You're like, what? This is really dumb, actually, that V-Ray doesn't let you rotate the dome lights because render engines like Redshift, for example, do allow this, and it makes sense that you should be able to rotate that node. So to rotate this in V-Ray, what you got to do, you got to go to the dome text, and then there's a placement node, a V-Ray place environment texture node right here. Don't know what that means. Don't worry about that. But basically, you have a horizontal rotation. So you can rotate this around this way, and you have a vertical rotation. Do it like this. Okay, so that's how you do that. That's a common question that you might get if you get like frustrated with, like, why can't I move this? Well, that's why. Okay, right. So I'm gonna turn this off, and then I'm going to just delete it. I don't care about that anymore. That can go. If I go back to V-Ray right here, you can see that everything is gone. There's no longer a default light anymore. It'll just say, hey, there's no lights, and it won't even give you anything. So it's just black. So next, I want to show you the sunlight. So we can say V-Ray sun, create a sun. And this will give us a little sun right here. Cool. Turn this back on. And this is not going to give us any type of environment. So we're going to have our like shadows be pitch black. But this is going to allow us to just rotate around here and then just have a look at what's going on. Okay, so to actually get some GI, essentially, what we need to do is go into our render settings. And if you go to overrides, environment, you can create your sun this way, and you can also create a sky. So you create sky, and this will create a V-Ray sky. Now, because the V-Ray sky is so absurdly bright, we have to create a view for our camera that is a physical camera node, basically, for our camera. So we don't actually have to create a camera. By default, any viewport camera is a camera, fully functional. So if you select this button right here, you can grab your camera, or you can just do perspective. I recommend that you do this on perspective and any other camera that you have, just so if you render from different views, you can actually use it. It's not like so blown out, unusable. And then the way you access the physical attributes, you go to Attributes, V-Ray, Physical Camera. When you do that, then you will get a physically accurate camera and all the different things like your aperture, your ISO, all sorts of stuff, okay? So it's pretty useful. All right, so next we need to grab our sun transform, and I need to zoom out here. And on this, actually, I'm gonna need another view for this. So I'm going to just click the space bar and go to a different view so you can kind of line this up. Or what you can do, this is kind of useful, right click over this menu and then say 2 planes side by side. So you can get one view here, and then you can get like a new perspective view. I can say new perspective. I can drag this wherever I want. I can do that over there, or get like a nice reflection, something kind of like that. Sometimes that's easier than having to zoom out and do it this way, because not all the lines show up. Okay, so this looks pretty nice. We got some nice reflections going on there. And then also you should be able to see your normal map. If you zoom all the way in, you can see like little cuts there. These are the highest resolution textures, so there are areas where it looks a little bit questionable if you get too close, but it's fine from the distance that we need. Okay. One thing I did forget to do, though, on the greebles, if I select the greebles there, go into the material. I forgot to change the reflection color there, so they're white. So that's very important. And next we got to do the glass. All right, guys, thanks for watching. In the next part, we're going to finish up with V-Ray materials, and we're going to go over glass. All right, see you guys in the next video.